time ago this. Can anyone give us the answer for the square root of x prime?
The 1/2 is x.
Very good. I should write to be exact. Why don't I? Because that's the inner function prime. I should have the inner function prime. Why don't I?
Because it's 1.
Because it's 1. But keep in mind that this is the formula that I'm getting at. If I have a function, can anyone give us the formula for the square root of a function, not x? It could be tangent. It could be 2x plus 1. It could be natural log. What will the formula be?
1/2 roots of the function times the function prime.
That's it. That's why I emphasized this from the beginning, so this comes easy now, and you don't have to think. Great. Okay, one more. Another important concept, and then I'll let you choose other problems in a minute. So when we differentiated e to the function prime, we got e to the function times the function prime, and I should have also mentioned that we should put in natural log e. Why don't I?
Equals to 1.
Because it's 1. Pay attention now when the base is not e. Like, let's say, any other base. A does not equal e. Raised to a function prime. What will the formula be? If it's e, I follow this. But if it's not e, I have to follow this. What do I mean by that? Anyone would like to give it a try?
Is it a the function power times the function prime times a would it still be ln e or ln a?
That's it. Because ln a is not 1. If it's 1, it's base e, but I don't have base e. So please keep this in mind because we're going to choose another example, and I hope we choose one of these. If not, I will. So let's go back. Yes?
So the a to the power of f, why can't we just do it like the normal differential way? Like making it like fa to the power of f minus 1?
Ah, very good question. Because this is a number. X is not a number. This is a number. X is the function. So this is n times x to n minus 1. This is a number. It follows totally different rule. See the difference? This is 2 to 3x. But this is x to the third. X to the third is 3x squared. But when I differentiate this, this is 2 to 3x times the inner function prime times natural log of the base. Very good question. Victoria is right. It looks the same. It's just something to a power. It just looks the same. It's not the same. It's a very good question. So here, this is the number. But here, this is the number, and this is the function. So the roles are reversed. Here, the base is the number, but here, the base is a function. When it is a number, I have to follow this rule. When it is a function, I have to follow another rule. Very good question. Is this okay, Victoria, now? Is it clear now?
Yes, thank you.
Awesome. Well done. See, if you don't ask questions, I would have never compared the two. So thank you. So when the base is the function, we follow this. It's the power rule. When the base is a constant, we are following the e to a function rule, so to speak. Great job. Okay, I'm sharing my screen. Let's work on anything you want. So this is very clear. If you want to choose that, it's up to you. But this is totally different. This is the base, right? I meant to say this is totally different. So here's the function to a power, but here is the constant to a function. So 35 and 36 are completely opposites. A number to a function to a number. So always pay attention to that. Thank you for pointing that out. Okay, I'm going slowly again from the bottom to the top. Of course, this is an exercise in endurance, but we can work on it, whatever you want. We have to choose at least two more so we can continue. Here we're asked to find the second derivative. If that's what you want, we can do that. Then we can find the equation of the tangent line. And you can say, what are you doing with this equation all the time, You will see in chapter 4 what I'm doing with and why we're after the tangent line all the time. Isn't the slope enough? No, it's not. You'll see what happens and what we do with that tangent line later. Okay, so from 60, I go back slowly. And if I don't hear anything, I will choose.
Maybe 48.
48. Y equals 2 raised to power 3 raised to power 4 to the x. A little bit of a test of endurance, but that's okay. We have to see this. My little rock. So I look at this function and I see a base, which is a number, and the power, which is a function. So if the base is a number and the power is a function, I have to follow this rule. So when I differentiate, I have to write the function as is, 2 raised to 3 raised to 4 raised to x. Then I have to differentiate this function. So let's write it in parentheses for now. 3 raised to 4 raised to x prime, leave it alone. So I copied the function as is. I wrote, without differentiating, I wrote the function prime, let it wait for a moment, times what? Times?
Extra log of 2.
Absolutely. So now I have to work on this piece because this is clear, but I have to differentiate that. Fine. So I copy the first part, 2 to 3 to 4 to x. And now I know I cannot forget this. Let me put it here and then we'll rearrange it so we don't forget anything. So now I have a base to a power. Oh, okay. To a function. How do I differentiate a base, a number, to a power? Okay, so I have to copy the function. So 3 to 4 to x. Then I have to copy in here 4 to x prime. And then I have to multiply by natural log 3. So I differentiated this. I copied the function. I put this, and I will immediately differentiate it, times natural log 3. Okay, fine. So I copy what is clear. I have 2 to 3 to 4 to x. I multiply by 3 to 4 to x. I multiply by natural log 2. I multiply by natural log 3. Remember, everything product, no addition, subtraction, times, okay, I'm here. Okay, what is this? Oh, not a big deal. 4 to x prime is 4 to x times x prime times natural log 4. Okay, fine. So 4 to x times x prime, but that's 1, times natural log 4. And it's done. You can rearrange it or not. It doesn't matter at this point. This is it. So get yourself a little rock. No, I'm kidding. That's why I need these prompts to help me explain what I'm doing. So take it very easy, slowly. Just say, okay, cover it up, because it's confusing. When I look at all those, they throw me off. But it's very simple. It's 2 to a function. I follow the pattern. Don't differentiate it. Normally we like to differentiate everything in one row, but this may not happen now. So then I have times this one. Okay, I copy everything else, and then I ask myself, how do I differentiate this? Nah, not a big deal. A number raised to a function, copy the function, differentiate the power, the function itself, not the power, the function, times natural log 3. Okay, then I put all these 3, 1, 2, 3, 4 in front, and then I'm here. Okay, final step. 4 to x, very clear. 4 to x prime is 4 to x times x prime, which is 1, times natural log 4. So get yourself your props when you have a function like that, and cover it up and slowly figure it out. And that's it. You can put 4 to x in front and just have natural log 3, natural log 4, doesn't matter really. Good pick. Okay, so let's choose another. What about 43? I'll choose a couple and you. So 43 is a good one. 36 could be a good one. 34 is ugly because of the square root. So that's another option. 31 is a very important one, to be honest, because of the simplification. 27 and this one here are exactly the same. Where was it? This one. So 36 or 31, I'm sorry, or 27 are the same. This is a product. Okay, so let's choose one more, please. Or I will. Anyone? No one wants to choose. Fine. Okay, I will. 31. You'll see in a moment why 31 is so important. Allow me to change r into x. It's easier for me to write. And 2x plus 1 to the 5th power. Okay. So we're asked to find the derivative of this function. And we have a lot here going on for us, or against us if you want. Quotient rule, power rule, chain rule. So it's a mouthful. So h prime of x. Every time I differentiate a quotient, I start by, that's me, by squaring this, which is power 10. Then remember 1 divided by 2 prime. I like to use this procedure. You can change the procedure, I'm fine. 1 prime times 2 minus 1 times 2 prime over 2 squared. I already have the 2 squared. 1 prime. Chain rule, a function raised to a power, and combined with the power rule, a function raised to a power. I bring the power in front. I subtract 1 from the power times the inner function prime because it's not plain x. So this is 1 prime. Now times the denominator, 2x plus 1 to the 5th power. Now I'm here with minus. Watch me run out of room. Okay, minus. I copy the first function, and now I have to differentiate the denominator. 5 times 2x plus 1 to the 4th times the inner function prime because it's not plain x. Look at that for the first time ever. Good. Now remember the keywords. Factors simplify. I would have to factor from this term and from this term the maximum possible. So obviously a 2 will go out. Obviously an x squared minus 1, to which power will go out?
2.
Exactly, the smallest of the two. Of course, thank you. So these are common. And also 2x plus 1 will come out to which power?
4.
Very good, the smallest of the two. Perfect. So let's see what is out. 2 is out, but 3x is in. X squared plus 1 squared is out, but only 4 of these are out. So there is 1 left over. And then minus. 2 is out, but 5 is not. X squared minus 1 to the 3rd, 2 are out, but 1 is still in. And luckily 2x plus 1 to the 4th is completely out. Any questions so far? Any questions? Now, only now, I can do this. Three x times 2x. 3x times 1. Negative 5 times x squared. Negative 5 times negative 1. Final step. 6x squared minus 5x squared plus 3x plus 5. And this is done.